Okay, another video going over your review for Chapter 3, Section 3. You were on the practice worksheet, numbers 2, 6, 10, 16, 20, and 22. I have done a little bit of this work so that the video wasn't quite as long. If you notice in number 2, it was a system of inequalities. You do have to graph the lines. They are in y equals mx plus b form. So you are going to plot the y-intercept for the first graph. Excuse me. Now, on your quiz, you're going to want to write and show, all of this work. Some of this work I'm going to do fairly quickly so that the video isn't quite as long. All right, there's my y-intercept of 3. And my slope is 1, so I'm going to go up 1 to the right 1, up 1 to the right 1. Or I can go down 1, left 1, down 1, left 1. I want to see how this... it is a solid line, so I am going to insert a solid line. Okay. Don't know why this wasn't. There we go. Best I can do. Now I am going to test the 0, 0 here. So maybe let me do this in a different color. If I test 0, 0, and this is what you're going to want to show on the test, okay? Hold on a minute. I have to go back to this, and hopefully it lets me draw it. So I do want to test 0, 0. All right? And when I test the 0, 0, I'm going to put a 0 in for y. 0 is less than or equal to 0 plus 3 is 3. That is a true statement. So I'm going to shade this side of the line. All right, now I'm going to choose a different color to graph the other line. My y-intercept is positive 2. My slope is positive 1 again. So I'm going to go up 1 to the right 1, up 1 to the right 1. I'm going to continue that pattern. I'm going to go and draw another line. It is solid because of the equal to. And so I'm going to start maybe here, try to go through those points. Slope is a little bit off here. I don't know if it's going to allow me. It's not, so let me try this again. I want to go in blue. But what you're going to notice and what you're going to see here is that because the slopes are the same, the lines are parallel. I'm going to try one more time. See if I can get this. Okay, so the lines are parallel. They're not going to intersect. And I am shading this side of the line. So your solutions, well, actually, I'm sorry. I overstepped. I want to test. So I'm going to test 0, 0. 0 greater than or equal to 2. Oh, look at that. Is 0 bigger than 2? No, that's false. This one was true. This one was false. So since this is false, I have to shade away from the 0, 0. So I'm shading this side. So actually we're going to see with this problem here is that where the shading is common to both is right here in between those two parallel lines. Okay, so I'm going to darken that in, and that's what I want you to do on your test. You got to darken in where the shaded region should be. So for that one, you're shading between the two parallel lines. Okay, because with respect to the first line, we were shading down underneath the line. With respect to the second one, we were shading up. And so the shading is common to both right there between. And that's where your solutions are. Okay, let's do number 6. So for The first line, look, I already did some of this work for you. You do have to solve this equation for y so that you put it into y-intercept or slope-intercept form, okay? The y-intercept is 2, and my slope is negative 1 over 2. Now remember, there was a 1 in front of this x, so when you divide by the 2, this is a half, okay? So I'm going down 1 to the right 2, because the slope is negative, down 1 to the right 2. Or I could go up 1 to the left 2. And you're going to draw that line. See if I can have this draw the line. Now it is dashed. So maybe I do not want to have this thing draw the line. It is dashed. Okay, so as best as I can, I'm going to draw my dashed line right through there. And now I'm going to test. I'm going to test 0, 0. So let me do that. Different color. I'm going to put a 0 in for y. Bigger than negative half times 0 is 0. Plus 2 is 2. Is 0 bigger than 2? No, that's a false statement. So because 0 is false, I'm not shading down below here. I have to shade on the other side. Okay? I'm not going to color this in all the way because that's just a waste of time. All right. Now I'm going to graph the other line. Look, after I solved it for y, the y-intercept is negative 6. My slope is positive 2. So up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. It is dashed again. Okay, so as best I can to make the dashed line to go through those points. Okay, it is a line, so I need arrows. Should have had arrows on all of these. Okay, and I need arrow here, I need arrow here. Okay, now I'm going to test the 0, 0 again. Okay, I'm putting it in here. 0 less than 2 times 0 is 0. Negative 6. Is 0 smaller than a negative number? No, that's false. So because that's false, I'm not shading on this side of the line. I'm shading underneath. Okay, so I'm shading right over here. Now look, where is the shading common to both together at the same time? Right in here. So you're going to make that darker on your quiz. Okay, you don't have to scribble and make it. It just needs to be more prominent so that I see where your solutions are. Okay. Number 10. Number 10 involved an absolute value. And so what you have to do with the absolute value is, make sure that the absolute value bars are isolated, and they were. Here's my value of C. So if you remember the rule, you take what's inside the bar, set it equal to 0, and solve for x, right? So x minus 4 equals 0, therefore x is 4. So your vertex was this x value and this y value. I put a plus 0 so that I saw it. My vertex is 4, 0. All right, I'm going to graph first the linear part. The y-intercept is negative 3. The slope is 1. So up 1 to the right 1, or down 1 to the left 1. Okay. It is a dash line because it's not equal to. So as best I can. There's my arrows for the lines. Now I'm going to test 0, 0. Okay, so I'm going to go in a different color here. I'm going to test 0, 0. 0 less than negative 3 is my result. Is 0 less than a negative number? No, it's not. That's false. So I'm shading this side of the line because 0, 0 made a false statement. Okay, the absolute value. My vertex is at 4, x is 4, y is 0. That's my vertex. Now, notice, I wanted a different color there. Notice, you do have to make a table. Okay, so we're going to pick 2 values to the left, 2 values to the right, and then you're going to substitute this into the original. 2 minus 4, negative 2, absolute value is positive 2. So I'm doing 2, 2. And then I've got 3, 1. And then I have 5, 1. So again, I did a little bit of this work so that the video wasn't quite as long. All right, there's my V-shaped graph. I'm looking, it's equal to, so I need solid line. Okay, so since it's going to be solid, I'm going to draw solid line. Okay, there's my V. I'm going to go back here. I'm going to put arrows on my V. And again, since my graph is not passing through 0, 0, I'm going to test 0, 0 again. Okay, so I'm going to put 0 bigger than or equal to, well, look, 0 minus 4 is negative 4. Absolute value of negative 4 is 4. Is 0 bigger than or equal to 4? No, that's false. So I'm not shading outside the V. I'm shading inside the V. Okay, so it's going to go this way, inside the V. Now, we are looking for where the shading is common to both together at the same time. And that is appearing as though that is only going to happen in this little space right here. Okay, where these things are coming together. All right, if you have questions, you have to reach out. Let's take a look at number 16. This is linear. They're both linear, and they are already in y equals mx plus b form. So, look here. My y-intercept is 0. Okay, so I'm going to put a dot on the 0. Slope is 3. Up 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. I am solid because I'm equal to. So I'm going to have this thing help me make a solid line. Yeah. All right, going back here, I'm going to draw my arrows on the lines. And I want to see where the shade, I cannot pick 0, 0 here. I cannot pick 0, 0. It's passing through 0, 0. So I'm going to pick 1, 1 instead. Okay, so for the testing, I'm testing 1, 1. Cannot pick 0, 0. When I test 1, 1, that's going to make 1 less than or equal to 3 times 1 is 3 plus 0 is 3. Is 1 less than or equal to 3? Well, yeah, 1 is less than. So I'm going to shade this side of the line because that's where 1, 1 is. And so since it's a solution, it would be in the shaded region. Okay, the next one. I'll do it in red, I guess. Y-intercept is positive 2. The slope is negative 2, so down 2 to the right 1. Down 2 to the right 1. Or up 2 to the left 1. I'm going to draw a line. It is solid. It is a solid line because of the equal to in the original inequality. So as best I can with this tablet writer, I'm going to draw my line. It's solid, like I said. I'm going to draw my arrows because it is a line. Those are important. You need the arrows. And this one does not pass through 0, 0, so I'm going to test the 0, 0. And I'll put a 0 in for y. Bigger than or equal to negative 2x plus 2. Oh, when I put the 0 in here, that's 0 plus 2. Is 0 bigger than or equal to 2? So again, is 0 bigger than or equal to 2? I don't like the way that looks. 0 is not bigger than 2, and it is not equal to 2. So that is false. So because that's false, that is not in the shaded region. So we're going to shade this side. And now let's look and see where the shading is common to both. Shading is common to both right here in this section. So you're going to want to darken that section. Okay? I just have to be able to see that I know that you know the shading is overlapping here. Again, you don't have to scribble this so much. Just make it a little bit darker. Or what you could do if you're writing in pencil, you could erase this part and erase this part and just show that it's overlapping here. You could use two colors as well. All right. Two more. Number 20. Again, they are both in y equals mx plus b form. And graph the first one, 2, and then I'm going to go up 3, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, or down 3 to the left 1. It is a dashed line because it is not equal to, so we're going to dash the line. The second one, I'm going to do my testing first for this, okay? It's not going through 0, 0, so I can test 0, 0. 0 bigger than 3 times 0 is 0 plus 2 is 2. Is 0 bigger than 2? No, it's not. That's false. So, because it's false, we're shading this side. All right, the next one. Y-intercept is 1. Slope is negative 2. So down 2 to the right 1, down 2 to the right 1, or up 2 to the left 1. It is solid because of the equal to. So I'm going to use my line drawer. There's my solid line. I'm going to continue the line up here. Okay, I'm going to go back here. I'm going to draw arrows on my line. And now we're going to test. Notice it does not pass through 0, 0. So I can use 0, 0. 0 less than or equal to 1. 0 is less than 1. So that's true. So I'm shading this side. Notice where the shading is common to both is right in here in this area. And so I'm going to make that more prominent to show that the solutions to this system is right here in this area. Okay, one more. Number 22, again, I did the chart already. It was absolute value, so you need a chart. You have to find the vertex. Remember, you do x minus 1 equals 0. Solve for x equals 1. And then the c value, or the constant here, that's your vertex, 1, 0. Then you pick two values to the left of 1, two values to the right of 1. You substitute these values into the original absolute value. To get what the y value equals. So if I put a 3 in here, 3 minus 1 is 2. Absolute value of 2 is 2. Okay. All right, let's graph the first one. The first one is linear. So my y-intercept is 3. My slope is 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, down 1 left 1. Okay, look, not equal to, so it's dashed. Okay, this one, absolute value. Well, let's do the testing first so that we get that out of the way. If you test 0, 0 here, because it does not pass through 0, 0, I'm going to substitute a 0 in for y. Less than 0 plus 3 is 3. Is 0 less than 3? Yes, that's true. So I'm going to shade this side of the line because 0, 0 gives me a true statement. So 0, 0 would be in the shaded part because it's a solution. All right, absolute value. I'm going to use that color. All right, my vertex is 1, 0. X is 1, Y is 0. All right, I'm going to plot these. Negative 1, 2. That's that point. 0, 1. X is 0, Y is 1. 2, 1. X is 2, Y is 1. 3, 2. Okay, look, not equal to, so it's dashed. This time the V is dashed. Okay, there's my arrows. I can pick 0, 0 to test if I want to. So when I test 0, 0, I get 0 greater than, look, when I put a 0 in here and subtract 1, I get -1. But you have to take the absolute value. Is 0 bigger than 1? Well, no, it's not. So that's false. So since that's false, you're shading inside the V. Now, notice, we were shading below this line, okay? So where the shading is common to both is inside here. So you're going to make that more prominent. Okay? So let me know if you have questions. And, I can help you. All right. Have a great day.